Hello again. I was kind of happy with the way that went, but I didn't like the quality of the board, so I cleaned it. It's probably never looked cleaner. Okay, so this is example 12 again, but part B asks us to do the same question, integral of this, but using a different substitution. There are some times when two different substitutions will give the same answer. Okay, I'm hoping that you'll see that this one is not as easy, or it's not going to be as easy. So let me just say from the beginning, part A was easier. That's the best substitution to make, but if it asks you to use this, you've got to go ahead and use it. Now, why is this different? Okay, well, you've got to differentiate this. If you remember, we had to replace the dx with du, and the only way of getting that is to differentiate what we're given a substitution. So how do you go ahead and differentiate this? There's a number of different ways, okay? Let me just talk you through them. So one way is to write it first of all as u is equal to 2x plus 5 to the power of a half. Now the only thing I don't like about that is you're supposed to have a positive or negative when you take the square root, aren't you? Okay? But differentiating that is going to be a little bit harder. Okay? So yeah, that's one method. Okay? Another method, so method 1, method 2. Another method, you could use implicit differentiation. Okay? Let me show you how that works. So implicit differentiation, this term will be 2u du dx. I'm not about to recap implicit differentiation, so look it up if you can't remember. And then on the right hand side, it's just going to be 2. And so from that, you can write down du dx is equal to 1 over u. Okay? And then from that, you've got dx is equal to u du. And you can just replace it in there. Alternatively, this is what you could do. Make x the subject, so I'm going to do that. So x is equal to u squared subtract 5 all multiplied by 1/2. And then when you do dx du, you're going to do half u squared, the derivative of that. So that's just going to be u. And then dx is equal to u du. Notice they're the same because they're two different methods and you should get the same result, okay? I'll say again, doing this, it's the longer way around, okay? Right, then you just substitute into here, or plug if you're an American, but I don't like the term plug, okay? Here, I've already rearranged that, so that's going to be a half u squared subtract 5, and then here, okay, that's going to be, well, can you see what it's going to be? If you've got u on its own, you would have root 2x plus 5, so that's just going to be u. And then this bit here is going to be dx, which is u du, so that's going to be u squared du. Okay. Obviously it looks slightly different from the first example because we're doing a different substitution. Let's expand the brackets, see what happens. So 1/2 u to the power of 4, that's going to be. Subtract 5 over 2 u squared du. Then we do the actual integration. So that's going to be u to the power of 5 divided by 5. And with the half there, because you're 1/10 u to the 5. Subtract, and this is going to be u cubed times by a third. So that's going to be 5 over 6 u cubed, and then plus c. And then we put in the expression for what u is. So 1/10 u to the 5. So that's this to the power of 5. So that's 2x plus 5 to the power of 5 over 2. Subtract 5 over 6. 2x plus 5. That's cubed. So power of 3 over 2 plus c. Okay? And you should, of course, get exactly the same answer, okay, which we indeed we do. I'll stop it and I'll do a separate video for the next example.